Hi, my name is Henry Brill. This is quiz 0. So for the first problem, when doing the derivative of this, you have to do the product rule. So 1 prime 2 plus 2 prime 1. So 1 in this case is e to the t. Sorry, I'm running with a trackpad, so it's not going to be very pretty. But yeah, it's e to the t. The derivative of that is same e to the t. So that's 1 prime. That's 1. And then 2 is sine t. And then 2 prime is cosine t. So is cosine t. All right, so 1 prime 2 plus 2 prime 1, e to the t, and then normal 2 is sine t. And then plus 2 prime 1. 2 prime is cosine t. And 2 prime 1, and then normal 1 is e to the t. So yeah. So yeah, that is y prime. Okay, now for the next question, you have to do chain rule. So pretty much for this one, you have to do derivative of the outside times derivative of the inside. Derivative of the outside, so derivative of negative cosine. Derivative of cosine is negative sine. So negative sine, and you keep the inside the same for this part. So negative sine, ln t, and then you multiply it by the derivative of the inside, and the derivative of ln t is just 1 over t. So 1 over t, and then, so this kind of, now simplifying this, we can get our final answer, where y prime equals negative sine of ln t and then that is all over t. All right. So add to t, not a very good t, but there. All right. Now for this next one, it's the definite integral of 1 over. Rewrite this as definite integral of 1 over x. Dx, and this one is just ln x plus c, and you have to make an absolute value because it's not, because ln is only, you can't put 0 or negative numbers in this, and then you have to add c. All right, this next one is a u sub problem. It's gonna be really fun to write with a trackpad. So I'm gonna set, in order to like see what I'm gonna do with u, I'm gonna try to find if there's like a function inside of this that I could take the derivative of and have it like cancel out. So I'm gonna set u equal to 4t cubed. Just for the sake of space, I'm gonna explain this one more, and then I'll write just like less steps, I guess, not all of them. So then take the derivative of both sides, in terms of t. Just do the power rule for this. Boom. All right, so do the power rule. That gives me 12t squared. And so now we have 12t squared equals du over dt. And we want to plug in for dt to get the integral in terms of du. So we have to multiply both sides by, we're trying to get dt. So multiply both sides of this by dt, and just this equals this still. And then divide by 12t squared, which will give us this. Du over 12t squared equals dt. And we can plug this into our integral. Plug this in for dt. And then once we have this, the t squareds will cancel out. So this leaves us, or they will divide, not really cancel out. This leaves us with, and we can move the 1 over 12 to the front of the integral. So 1 over 12, then integral, and then the t squares, they divide each other out, and we can sub u in. So this just gives us, and then e, and then since we know u, our original u was 4t cubed, we can just plug in u. Du, and we know the integral of e to the u is just e to the u. So yeah, now we got, that's just an arrow. We just got 1 over 12 times e to the u plus c. And one last step after this. Oh boy. Okay, yeah, one last step after this is substituting back in for u. So we have to get our answer in terms of t. And we can just use our original u value, which was 4t cubed. So final answer for this one, excuse me, is 1 over 12 e to the 4t cubed plus c. And that's our answer for that one. All right. Now for the next one. So this one, there's a lot of identities and stuff. So the first one I'm gonna do immediately is a Pythagorean identity, where I get this and cosine squared x plus sine squared x equals 1. So that just simplifies into 1. So gonna put that there. And it doesn't have to be necessarily x, or it could be, if they just have to have the same argument. So yeah, cancel those out. We use those. Those are gone. All right. Now we got minus cotangent, which cotangent is the same as cosine over sine. So if we multiply the top of this fraction by, if we just do times sine of 2x on the top and bottom, then, actually no, sorry, to do this even quicker, we know 1 over tangent is cotangent, so 1 over cotangent is tangent, because they're like inverse, so we could just rewrite this as minus tangent of 2x. Which works nicely, and it you could just subtract it from tan 2x, so we can get rid of both of these now. So we have the 1 from over here, and we have the minus cosine x of 1 over sine x. So now this final part is you could do Okay, so sorry, I'm just trying to draw this here. So 1 and then plus negative cosine x cosine x times 1 over sine x, not cosine of 1 over sine x. Cosine x times 1 over sine of x, which we can just rewrite as cosine x over sine x, which is the same thing as cotangent. So we can just rewrite that as 1 minus cotangent x. And yeah, that is as simplified as it can get. Let me just rewrite this though. So 1 minus cotangent and x. That's the final answer for that one. Okay, cool. Draw arrow. Okay, now for the last problem, this one uses like a lot of log rules. The first rule that I'm gonna do, or first like part that I'm gonna rewrite, so is we keep the first one the same, and when you have something that's in front of the ln, you move it to the power. So this turns into ln t cubed of minus ln t squared. And another, before we move on to the next term, another like log rule is that when you're subtracting two logs, you divide their arguments. So this would be ln of t cubed over t squared, which just leaves us with ln of t. So we could rewrite this as ln of t, and then plus ln of t minus e. Yeah, and now the next rule is that when you're adding two logs or natural logs, their arguments multiply. So this gives us our final answer now, and we have ln, draw parentheses here, t squared minus t e, because the t has to distribute. So yeah, and that's our final answer. Cool. Thank you.